Hello students, welcome back. Previously we studied the method of substitution. Basically we select one equation, select a variable, solve it, and substitute it to the other equation and then go from there. That's the method of substitution. Now let's study the method of elimination. A little bit different. Instead of solving for a variable, we are trying to eliminate a variable. How do we do that? From here in this system, please note that we have x and we have 2x. So if I multiply by -2 here and make this into -2, -2x plus 2x, they will cancel each other out. That's the idea. Therefore, I decided to multiply -2 to the second line here. That gave me this equation, which I just highlighted in blue. Please compare the second line highlighted in blue, multiplied by -2, multiplied by -2, so no change. I can multiply the same thing to the left-hand side and right-hand side of the equality. No problem there. So the first system here and the second system down there are equivalent. But the second system is a little bit easier to work with because I can now add them up. Left-hand side and right-hand side are the same, so I can add the same thing to both sides of the equality, left-hand side and right-hand side. So if I add them up, 2x minus 2x, that's going to be gone. So that part which I just highlighted in bold, gone. And that part, gone. And then we have 3y minus 8y, which is -5y. And then to the right-hand side, we have 6 plus 2 is equal to 8. So we get y equals -8/5. So that's the idea behind the elimination. Multiply a strategic number so that I can add up and eliminate. Now that I have y equals -8/5, I can do the same thing as before and plug it into the other equation and then solve. Yeah, I can do that, but for the instruction's sake, let's do this elimination again. So let's come back here, original equation. This time let's eliminate y. So 4 and 3. So multiply 4 to the first equation, which I'm just highlighting in green. And then multiply -3 to the second equation. So multiply by 4, then this will become 12. Multiply by -3, this will become -12. 12 minus 12, that's how you can eliminate y. Here we go. Look at the green equation, the first equation. That was obtained by multiplying 4 to everything from the first equation here. Compare. Now this blue equation was obtained by multiplying -3 to each term from the second equation here. Multiply by -3 to each. And then add them up. That'll kill off this plus 12y, this one, and then minus 12y, that one. They're going to cancel each other away, and then we have 8 minus 3, so 5x, and 24 plus 3, 27, so x is 27/5. So this way we don't do any substitution. We just do all the elimination, and then you can get everything. This method is called the method of elimination. Now, this method works only for systems of linear equations. It doesn't work for a system of nonlinear equations, so I'm doing this in an optional lesson here. But this method, the elimination method, has its own advantage. It can be made into completely algorithmic fashion so that computers can handle very, very quickly. So elimination method is related to the use of computer algebra system and a bunch of other things as a matter of fact too. Okay, here's another example. This time we have system of nonlinear equation. First equation is linear, but the second equation is nonlinear. In this case, the elimination will not work. We have to use substitution. And that's why the substitution method is the default method. That's a standard. And then I'm covering elimination method in optional video here. So how do we work out this kind of problem? Well, solve for one variable and plug into the other. So from the first equation here obviously I decided to solve for y. And then here we go. Solve for y and we got this. And then substitute this one in place of y in the other equation. So if I do that, it's a little bit difficult to see here, okay? We got x times y, come on. X times y is equal to 4, alright? Negative 4, excuse me. And then here, I'm substituting y as this x expression. So x times, and this goes in there. Make sense? This one here, which I just highlighted in red, is going in place of this red. And if we rewrite, you can rewrite like this, because the multiplication applies only to multiplication to numerator. Or here, denominator over 1 is hidden. So x times numerator, 1 times 3. Either way, you can go like this. And then you can eliminate the denominator by multiplying by 3. Alright, we have the parentheses, but no denominator anymore. Break up the parentheses and work out, we get a quadratic equation. Solving this quadratic equation is not too bad. You can simplify and factor it, and then we get two solutions. X is equal to negative 2 or x equal to 3. And how do you find that y value? Well, we have it here. So plug it into x equal to negative 2, we get y equal to 2. X equal to 3, we get y equal to negative 4/3. And those are the solutions. It's an example of the method of substitution, but for nonlinear equation. You see, you ended up with quadratic. So, if you have a system, substitution method always works. Elimination method doesn't always work. Therefore, the substitution is a default, even though it's not always the best.